Welcome to Motors and Generators, 2018 Canadian Electrical Code Training.
It is your responsibility to understand and apply all requirements of the Canadian Electrical Code Part 1, including those not addressed in the training. Do you want to know how?
Hi, I'm Cameron, your subject matter professional for this learning. I will help you to understand and apply the requirements of Section 28, Motors and Generators of the Canadian Electrical Code, Part 1.
The aim of this training is to provide new knowledge and to support the development of new skills that you can apply immediately to your job. The purpose is why you are taking this learning. To directly support the purpose, this learning has identified objectives. Here is what you will learn as you take this training. Save or print a copy of the Quick Reference Guide. It is located in Resources. Use this Quick Reference Guide to take notes and as a practical job aid for this code section.
The principal components and requirements for motor installation are summarized in Figures 28-1 and 28-2, which provide an overview of the supply to a motor control center typically used to feed the individual motors in a multiple motor installation. The following terminology is used throughout this course. Click each term to view the definition. Select to learn more. Horsepower, HP, used to size the starting equipment for the motor and to determine the full load current if it is not given. Revolutions per minute, RPM, speed of the motor in revolutions per minute when the motor is fully loaded, operating at its rate horsepower. Volts, required operating voltage of the motor. The HP Torque's full load current ratings are based on this voltage. Select to learn more. Amps, also called full load current. It is the current the motor will draw at its rate of voltage, driving or supplying its rated load and horsepower. Service factor section is a multiplier which, when multiplied by the horsepower of the motor, will indicate how much the motor can be overloaded. Select to learn more. Code is a NEMA code letter designating the locked rotor kVA per horsepower. For example, the letter F allows for 16 to 17.99 kVA per horsepower, 50 HP locked rotor kVA. 50 times 16 equals 800, and 50 times 17.99 equals 899.5 kVA. Phases, the type of electrical system the motor will work on. Code is a NEMA code letter designating the locked rotor kVA per horsepower. For example, the letter F allows for 16 to 17.99 kVA per horsepower, 50 HP locked rotor kVA. 50 times 16 equals 800, and 50 times 17.99 equals 899.5 kVA. Select to learn more. NEMA nominal efficiency refers to the efficiency, the ratio or comparison of useful power output to the power input, expressed in the same units. TEMP refers to ambient temperature and is the maximum temperature surrounding the motor. Insulation class indicates the required temperature rating of the motor's supply conductor insulation when it is within 1.2 meters of the motor's connection box. See Rule 28-104 and Table 37. Duty requirement of service that demands the degree of regularity of the load. If the motor nameplate is not available, refer to the manufacturer's catalog or spec sheet. FLC for motors, AC three-phase motors, Table 44, AC single-phase motors, Table 45, DC motors, Table D2. If duty service is not known, assume it is a continuous duty. If a service factor is not known, assume a service factor of 1. Elements of a motor circuit requirements are outlined in Section 28. Wiring methods, conductors, 100 series rules. Overcurrent protection, 200 series rules. Overload, overheating protection, 300 series rules. Undervoltage protection, 400 series rules. Control, 500 series rules. Disconnecting means, 600 series rules. Hermetic refrigerant motor compressors, 700 series rules. Multi-winding and part-winding motors, 800 series rules. Motors are heat-producing equipment, which means they must be protected from overheating, have a temperature rating suitable for the location in which they are installed, connected with conductors suitable for the temperatures that can result from the motor's operations in a given ambient temperature, not exceed ignition temperature of substances that make contact with the motor. The following factors impact motor temperatures: ambient temperature, unbalanced voltage, low voltage, load driven by a motor, accumulation of dust. Motors may be supported or mounted on pads or springs to reduce noise and vibration transmissions to other parts of a building or structure. Appendix B recommends that when rigid conduit, EMT, or other rigid wiring methods are used to make connections to a motor connection box, a flexible fitting be inserted between the rigid conduit and the motor terminal enclosure to prevent vibration transmission and damage to the rigid conduit or other rigid wiring arrangements.
Flexible cords used to supply portable motors may be subject to severe usage, such as being dragged or moved along rough, dirty, uneven, or wet surfaces. Flexing, vibration, and mechanical injury from being walked on or driven over by machinery. Therefore, Rule 28-102 requires that flexible cords supplying motors have a serviceability rating of not less than that of Type S cord unless the motor forms a part of a motor-operated device. An exception to this requirement is allowed when the motor is a part of a factory-assembled device, and the rating of the flexible cord is covered by the standard for the specific equipment.
When ambient temperatures are higher than 30 degrees Celsius, as shown by Table 37, Rule 28-104 requires insulation temperature ratings value be increased by the difference. Therefore, it must be equal to or greater than Table 37 value unless marked otherwise. This is based on a 75 degrees Celsius rating. The exception is when Class A motors based on 90 degrees Celsius rating, when 90 degrees Celsius conductors are used. If the temperature rating is greater than 75 degrees Celsius, the conductors must be at least 1.2 meters long and terminate at least 600 millimeters away from any part of the motor for motors up to 100 horsepower, as shown in the diagram. For motors 100 horsepower and larger, these conductors must terminate at least 1.2 meters away from any part of the motor.
Continuous duty motors must have an ampacity equal to or greater than 125% of the nameplate current. Non-continuous duty motors must have an ampacity equal to or greater than the multiplier from Table 27 times the nameplate current. When feeding 2 or more motors from a single set of overcurrent devices, the ampacity of the conductor must be equal to the branch circuit, or tap conductors are permitted provided they do not exceed 7.5 meters and are equal to 1/3 the ampacity of the feeder.
Time for a checkpoint question.
Based on the FLA and the service classification of the motor, Rule 28-108 requires ampacity for feeders supplying 2 or more motors must have an ampacity meeting the following requirements. If all motors are continuous duty, the minimum feeder ampacity equals the FLA of the largest motor. Multiply 125% plus the FLA of the other motors on the feeder. If all the motors are non-continuous duty, the minimum conductor ampacity equals the sum of all the calculated conductor ampacities for the individual motors.
Time for a checkpoint question. Tap conductors from a feeder to a single set of overcurrent devices protecting a motor branch circuit may be sized the same as the branch circuit conductors if they are enclosed in metal and are no more than 3 meters long. They have an ampacity not less than 1/3 of the feeder and are protected from mechanical injury. Let's take a look at the process of calculating the tap conductors from a feeder to a single. Let's take a look at the process of calculating the overcurrent protection for individual motors.
The branch circuit overcurrent protection required by Rule 28-200 Subrule 2, Item E, permits the use of a self-protected combination motor controller.
Time for a checkpoint question.
Where power electronic devices are used in a solid-state motor controller system, semiconductor fuses shall be permitted in addition to the protection determined by Rule 28-200, Subrule 1, provided that the semiconductor fuses are integral to an approved controller.
Semiconductor fuses are components recognized in accordance with CSA C22.2-248.13 and provide short-circuit protection, but they may not provide overload protection. Rule 28-212 requires that in cases where power electronic devices are used in a solid-state motor control system, semiconductor fuses are allowed to be used in addition to the protection determined by Rule 28-200A, which states that the full load current shall be multiplied by the Table 29 factor, provided that the semiconductor fuses are integral to an approved controller.
Maximum ampacity of the feeder overcurrent device is calculated using the following. Rule 28-204 provides the requirements for feeder overcurrent protection. When all the motors can start simultaneously, the maximum rating of the overcurrent protective device is determined by taking the highest calculated value of branch circuit overcurrent protection in the group of motors being fed off a common feeder, and adding to this value the FLAs of all the other motors on the common feeder.
Max rating of overcurrent protections for simultaneously starting. Example: total FLCs of all motors starting simultaneously equals 272.1 amps. Maximum rating of a non-time delay fuse. Table 29 value equals 300%. 272.1 times 3 equals 816 amps. Less than maximum permitted value of 975 amps. Standard rated fuse will be 800 amps. Types of overload protection. Separate devices are responsive to motor current, which are permitted to combine the function of overload and overcurrent protection if it will open under both short circuit and overload conditions. Protective devices are integrated with the motor that protects the circuit conductors and the control equipment and is responsive to motor current or to motor current and temperature. If fuses are used as overload protection, they must be time delay fuses. The number and location of overload devices required. If fuses, one in each underground conductor. Otherwise, see Table 25. Time for a checkpoint question. Rating or settings of overloads are based on the service factor, SF, of the motor. If the service factor is 1.15 or more, FLA times 125%. Or, for example, if the service factor is less than 1.15 or not marked, FLA times 115%. The calculated value equals the setting of overload devices if of the adjustable type, the maximum value of overload device if of the fixed type. Overload protection is not required if the motor is 1 horsepower or less and continuously attended while in operation and is on a branch circuit with up to a 15 amps rating, a branch circuit with protection calculated using Table 29, and it can be readily seen/heard from the starting location that the motor is running. A motor part of an integral assembly that is automatically started and rated 1 horsepower or less. A motor that complies with CSA code 22.2-77. Undervoltage protection disconnects the motor from the source of supply and is either low voltage protection, which is relevant when the automatic restarting of the motor could potentially injure someone, or low voltage release, which is relevant when it is desirable that the motor restart after the power has been restored. Individual motors disconnect must be manually operated and capable of simultaneously disconnecting all ungrounded conductors. They may be fused or unfused and must be horsepower rated no smaller than the HP rating of the motor. Group of motor disconnects must be rated at least 115% of the FLA of the largest motor plus the FLA of all other motors in the group, and have a horsepower rating at least as high as the largest motor in the group. Manually operated across-the-line type of motor starter marked suitable for motor disconnect. The most common complaints about these manual motor controllers are that the contacts have fused closed, leaving one or more phases live when the switch was turned off. There is evidence of considerable contamination, condensation, and corrosion in these units after just a few years' service, and many of the failed switches have arced across the terminals. Currently, electrical inspectors are approving installation of this type of switch to comply with 28-602-3B. Manual motor controllers marked suitable for motor disconnect on all HVAC rooftop units. However, these manual motor controller switches have not been certified by CSA for use on circuits that contain motor branch circuit overcurrent protection. Fuses on the load side of the switch. An enclosure that contains the disconnecting means for an air conditioning, refrigeration, or heating unit and that is located outdoors shall be suitable for the environment, and where conduit is used as part of the wiring methods to the disconnecting means located in the enclosure. The conduit shall be drained and sealed in accordance with Rule 22-302. The intention is to prevent the rapid contamination, condensation, and corrosion that is occurring at this type of equipment from the passage of air between the building's interior and the outdoors. Select to learn more. HVAC disconnects must be located within sight and within 3 meters of the equipment. The refrigerant from the compressor to cool the motor may have higher horsepower ratings than standard equipment. Must be marked with both rated load current, RLC, locked rotor current, LRC. If horsepower rated equipment, LRC equals 6 times FLA. FLA, RLC can be determined from Table 44 or 45, as with other AC motors. Time for a checkpoint question.
How well did you do? How well did you do?
You covered a lot in this course. This summary helps you to recall the main concepts and requirements of this code section. You have now completed the learning on the main concepts and requirements of this code section. Next, you will take the open book quiz through the link on the course page. Click Close to exit and then start the quiz.